So this type of problem here that we're about to look at is basically what the second half of Chapter 5 is about, which will be taking something like this. It's not factorable from any of our methods. If you tried to use factoring by grouping, it wouldn't work, and that would be our only option since it's 4 terms. So we're going to use synthetic division and this new way to generate possibilities to factor this thing down. So let's create our list of possible x-intercepts, which would be plus or minus, factors of 2, and then out in the front, factors of 15. So then we just group all those numerators up with those denominators. So the 1 would be paired up with all those. So we've got plus or minus 1, plus or minus 1/3, plus or minus 1/5, and plus or minus 1/15. And you go up and you'd factor in all the ones of the 2's. So we'd have plus or minus 2. We'd have plus or minus 2/3, plus or minus 2/5, and plus or minus 2/15. So by all means, feel free to plug any of these into this equation and see if they turn into 0. That'd be a big hassle. Instead, for the test, we're going to look for x-intercepts on our calculator. All right, knowing that they have to be from that list. And calculator. Okay. All right, so using our calculators and this list, we'd cross-reference and find that these are our x-intercepts. So now we can use synthetic division, which would be us writing the coefficients from that original equation. So we got 15 minus 32, 3, 2. We'll be adding it up. Now this part gets a little tricky for some people because it's a lot of like, is it the opposite or not the opposite type thing in terms of deciding what number I'm actually going to need to put out front. When we first learned it, I'd given us stuff to say if I wanted us to divide by the factor of x plus 4. The number we'd actually plug in would be a -4 because that was the x-intercept for that factor. What we just found here in red are the x-intercepts. So I do not want to take these numbers and then flip them back, right? Because the whole time when you're doing synthetic division, you're using the actual x-intercept, and that's what we found in red. Those are the x-intercepts, so I want to use those x values. You have to think opposite when you're given the overall factor, and you have to trace it back to your x-intercept. Okay? So now looking at these, you would have the option to do -1/5 with synthetic division, 1/3 with synthetic division, or a 2. So if you wanted to choose a fraction, more power to you. But all 3 of them are going to work. We already know that because we saw them as x-intercepts on the graph. But I'm going to choose 2 because that's going to be way easier than any of the fractions. If you did the fractions, though, for fun, it would work out and get you a remainder of 0 as well. So the 15 first term always drops down. To get back inside, you got to multiply it by the number in question, which is 2. So we get a 30. Add those up for a -2. Multiply by 2 to get it back inside. Add those up to get a -1. Multiply by 2 again to get the -2. And then there's our remainder of 0, which we've totally expected because we already knew that 2, 0 was an x-intercept, which means it has to have a remainder of 0. So in terms of factoring this, if this 2 was an x-intercept, its factor would have to be x minus 2. Right? X minus 2 is the factor associated with the x-intercept of 2, 0. All right, and then remember to find out what's left over. These are your coefficients, except it's going to start off 1 power lower than it was in the first place, which we started off x cubed. We just divided out 1 term of x. So now it's going to be x squared. So we'll have 15x squared minus 2x and minus 1. Okay, so this is where we used to stop, but now that we're in the second half of Chapter 5, we'll actually keep going and we'll factor this piece as well. And we know it factors because we already saw that it had whole number and or fraction x-intercepts. since we already found our x-intercepts, we can actually use that to help us continue this factoring process. But before we do that, you could do synthetic division on this one more time using either 1/3 or -1/5, and it would factor it out for you. That would also be another option, but most people at this point would just choose to factor this by hand. So, but looking at our factors, this 3 and 5 are telling us that these are going to have to start with a 3x and a 5x. Right? And the numerators will actually tell us the c values, which would be 1 and 1. And then at that point, we just need to set up the proper signs to make sure we get a -2x, which would be putting the negative right there. Okay? So we just fully factored a x-cubed situation, which we've never been able to do unless it was SOAP, and then it was a special scenario. But this is the first full run-through of what the second half of Chapter 5 is about, fully factoring things that require us to first use synthetic division. All right, and so we'll see some more of these. Sometimes there might be 4 factors in there, and we'll be able to find it using the same process. It just might just take 2 sets of synthetic division to find that. All right, so we just covered what to do when everything's going well, when this one had 3 factors and it had 3 whole number or fraction x-intercepts. But as you all are aware, sometimes we get solutions that are irrational. So they have the square root in there, or even the square root of a negative number to get an imaginary solution. And we're going to get more into this as we get into 5.6. But this is kind of a good introduction here. Okay, so if we have a polynomial with rational coefficients, which means whole numbers or fractions, and we're lucky to get an irrational number, and an irrational number is just anything under a square root that's not a perfect square, right? As a solution, then its conjugate, negative square root of that, is also an answer. And all that is anytime we found a square root solution, remember that you always had to put that plus or minus. So it's just saying if they tell you one of your solutions is like an x is a square root, you know the negative version of that same number also has to be a solution because of the plus minus. Okay? And then if we had a complex solution, and those look like a plus and then some amount of I, sometimes a is 0, but basically some regular number and then some imaginary number, then its conjugate is also a root, which would just be a minus bi. But that's the exact same concept. Because remember, I came from square rooting negative numbers, so once again, you'd have that plus or minus going on. All right, so this sounds more complicated than it is. Here's what these questions will look like. Polynomial. They don't tell us what the polynomial is, but they tell us it has solutions of 3 plus I and square root of 5. It wants to know what's its other 2 solutions. Well, if square root of 5 is 1, then negative square root of 5 also has to be 1. And if 3 plus I is 1, then 3 minus I has to be 1. Okay? And that's all it is. Right? So this is actually pretty easy. And they come in pairs, all because of that plus minus symbol, which comes about any time we're taking a square root. So it says, what is a third degree polynomial function that has solutions 3i and negative 5? Now, negative 5 is not a square root, nor is it an imaginary number. So don't just start doubling everything and saying that it also has one of 5. That's not true. This is only true for square roots and imaginary. So I could go ahead and factor this one. This one would be x plus 5, right? That's the piece associated with that. Now, if 3i is one of our answers, then negative 3i also has to be 1. So this part will seem strange at first, but this means that x plus 3i and x minus 3i are also factors. Okay? And then to find out what the full thing is, we have to multiply this out. With just regular FOILing, right? So we get x times x is x squared. We get minus 3xi plus 3xi. Those would simply cancel. And then we get a minus 9i squared. I squared is a negative 1. So when I multiply those first two pieces together, that's saying that, hey, x squared plus 9 is one of our factors. And then if you just took that and multiplied it by x plus 5, you'd be able to get the original polynomial. So that'd be x cubed plus 5x squared plus 9x plus 45. So we just found the equation. It's supposed to be a y equals there. We just found the equation that would have the zeros at those exact spots. And it would be x cubed plus 5x squared plus 9x plus 45 has these as solutions.